So how do you go about updating a document once you've got it? And as a side note, who's got time to seek on disk anymore? One of the fundamental drawbacks of traditional RDBMS technology in the age of modern hardware is that it's a disk-first technology. It takes time to write everything to disk first and then log it for availability, and then eventually cache an index of it in memory for ease of use if you ever actually want to use it again. So virtually all reads and writes need to seek on disk. By contrast, Couchbase and other NoSQL technologies take a memory-first approach. If you know the history of Couchbase, caching is directly in our DNA. We cache our data in memory. If necessary, it's replicated for availability. And yes, we do write it to disk, but your reads and writes can be served immediately from memory. That's why we scale way beyond the capacity of traditional RDBMSs. So how do you update a document once it's already in the bucket? Well, the bucket exposes a replace method. It takes a document, likely a JSON document, and as you've seen in a related method, you can specify persistence, replicas, and a timeout here as well. So this replaces a document if it exists. It does test for the existence of the key before it does the update, and it does throw an exception if it doesn't already exist. Keep that in mind, the fact that an replace does test for existence. Now you can set the disk with further replication constraints if you want to force creation of 1, 2, or 3 additional replicas in addition to the original document. As we've said elsewhere, look for best practices around this before assuming you need to create replicas. You can also set persistence constraints. Now, normally a replace operation is acknowledged as soon as the replace happens in memory, but you can cause the acknowledgement to wait until the replacement has been persisted to disk, and so on, if that's necessary for the requirements of your application. You can also set a timeout, and it returns a document with an updated check and set value. As we've said, we'll talk about CAS or check and set more in a later lesson. So as we've seen, you may expose a method in your API called update, which receives one of your local domain objects, and that object may need to go through a conversion process from a POJO to a JSON document. And then that JSON document is simply passed to the replace method of a bucket. What comes back is another JSON document, but with an updated check and set value. And then that can go on through the rest of your application in manners you've already seen. You can use a query method for this approach as well. Our Nickel language does support an update method if you need to take more elaborate client-side approaches to what it is that you're merging and updating back to the server. So when might a replace operation throw an exception? Well, it could happen if the particular request times out. It would also happen with a replace if the document does not exist. It also could be thrown if the check and set value doesn't match. We'll talk about that more in a later lesson. The other exceptions we've talked about are also available: back pressure, request too big, request canceled, temporary failure out of memory, and so on. So in this lab, what you're going to do is replace or update a document, noticing how similar it is to doing a GET. Now I'm going to go to Lab 8 to show the solution. You'll actually work on Lab 7, just reminding you that they are staged solutions. And in our Couchbase repository code, I will go to the update method, and you'll see, as shown, we simply convert our entity to a document and replace it. That replacement sends back another document with an updated check and set value that we pass on through the rest of the application. Again, I hope you jump in and choose to work things through in the workbook to get a close view of how this is all behaving. It's good for learning purposes, and we'll see you in the next lesson.